Hi everybody. I apologize, it's taken a long time to get these up here. Before I go, I want to tell you about a little formatting issue. What I'm going to do is I'm going to write the word flash over any reaction, any question that I want you to make a flashcard for. I'm going to do that for the reactions that can't be done using your cheat sheet and can't be done using the connect and cancel method. This is primarily just to let you know that there's about 5 reactions on here that are really obscure and you're just going to have to memorize. So as you go through the worksheet, the AP Chemistry Chemical Equations worksheet that I gave you, I want you to make a flashcard for that reaction and the answer for any that I write flash on the screen for. So as I go here, this first reaction, A, is one that I would like you to make a flashcard for A. So for a solution of ammonia is added to a dilute solution of acetic acid and identify the conjugate acid-base pairs in this reaction. You do have the answers on the worksheet and I'd like you to make a flashcard for that. I'm going to change. Okay, this next one, solutions of sodium hydroxide. All right, it's a solution. Sodium hydroxide is a strong base, so it's going to be separated in water. It's mixed with acetic acid, which is a weak acid, so it's not going to be separated. I see ions, so I'm going to connect, and I'm going to cancel. Sodium acetate is soluble in water, so it's going to stay apart, and water, or HOH, does not. We cancel out the spectators, and it's balanced, so the reaction written above is correct. You can just leave it that way. It asks if it's basic, pH greater than 7, neutral, pH equal to 7, or acidic, pH less than 7. The answer is basic. Okay, strong base versus a weak acid. In this case, the strong base is going to beat out the weak acid. B or C, hydrogen sulfide gas. Okay, it's a gas, so it's not going to be separated. You're going to keep it together. Is bubbled through excess potassium hydroxide solution. We're going to write that in the ions. It's a strong base. I see ions, so I'm going to connect and cancel. In this case, I'm going to get water, HOH, liquid, and I'm going to get the soluble potassium sulfide. Potassiums are going to cancel, and I'm going to rewrite this one for you. I'll be left with H2S plus the hydroxide ion, and that's going to form water plus sulfide. I'm going to have to balance the hydrogens by putting a 2 here and a 2 here, and I'm good to go. Write the successive ionization equation for H2S. What ionization means is you write out equilibrium reactions showing the loss of all the potential hydrogens. In this case, there are 2 hydrogens, so we're going to have 2 reactions. In this case, there's 1 more hydrogen left to lose. And notice how the charge goes from -1 to -2. Each time you lose a hydrogen, the charge goes down. Those are the 2 ionization reactions. Reaction D, barium oxide, and that's a solid, so it stays together, is added to distilled water. All right. In this case, we have a metal oxide, and that's reacting with water. Anytime a metal oxide reacts with water, we get the subsequent strong base. Watch out for alkali metals in water. They also do the same thing, but those do produce hydrogen gas. This is not an alkali metal, it's just a metal oxide. The resulting solution is basic because it produces good friend OH minus. There it is. Solid calcium oxide is exposed to a stream of carbon dioxide gas. Solid calcium oxide. Oh, again, on that previous one, I forgot to mention, guys, you are going to go to the cheat sheet in this reaction because you do not see any ions. Okay, let's go back. Solid calcium ions is exposed to a stream of carbon dioxide gas. Okay, we do not see any ions in this reaction either, so we're going to go to the cheat sheet. We got a metal oxide That's reacting with a non-metal oxide. Metal oxides reacting with non-metal oxides form the associated ionic compound that is a polyatomic, and that polyatomic comes from the other elements, the non-metals that do not include that metal. What type of reaction is this? We can call this a combination reaction. We can call this a synthesis reaction. And basically two things are going to one. Combination, synthesis, both work fine. Next reaction. Solid, dinitrogen, di means 2, and pent. That equals 5. So we have N2O5. It's added to water. Okay, I do not see any ions, so I'm going to go to the cheat sheet. I see a non-metal oxide reacting with water. We're going to form the strong acid that involves all the elements. So a strong acid is going to start with H plus and it's going to be separated. Now the only strong acid that involves nitrogen and oxygen is nitric acid. And that's going to have an NO3 minus 1 in this case here. Is the final solution acidic or basic? Let's go back and balance this reaction before we start. You're going to have 2 hydrogens. You're going to have a 2 here, 2 here, 6. Okay, that takes care of it. Is it acidic or basic? What do you guys think? It's going to be acidic, produces hydrogen. Acidic produces H plus. I believe non-metal oxides with water is on your cheat sheet. If it's not, please let me know in class. G, carbon disulfide vapor is burned in excess oxygen. This is one that I'm going to have you make a flashcard for. Yeah, that's not on the cheat sheet, and I also want you to make a flashcard for the question. Not really sure how they got about that answer. It's fairly obscure, so make a flashcard for that. If you memorize it, chances are you're going to get it right on the test. Lithium metal is burned in air. Okay, lithium, Li0. Burned in air, oxygen gas. If they said burned in nitrogen, you'd put nitrogen. Okay, no ions, going to go to the cheat sheet. We see 2 atoms. If we see 2 atoms that both are neutral, one's got to go up in charge, one's got to go down in charge. Lithium's an alkali metal, it's going to go up to Li plus 1. Oxygen, we know, always makes a minus 2 charge. There's no presence of water. It's going to be a solid, and we're going to balance it. No ions are shown. Now, other than a combustion, because they said it actually did use O2, kind of a generic combustion reaction, we can call this a redox reaction. Redox, because there was change in charge, Li was oxidized, so it's the reducing agent. O2 was reduced, so it's the oxidizing agent. There's change in charge. Change in charge equals redox. Okay, what I'm going to do is stop right now and move on to the next vodcast. So when you go to the website, you're going to click on vodcast 2 for the more reactions. I'm going to stop this one here due to space issues. See you on problem. The next problem, guys. Take care.